In this topic video, we're going to be talking about the boundedness theorem for a polynomial. And what this theorem is it may seem a little odd, but say I've got some polynomial, p of x, and again, it's equal to a times x to the n plus b times x to the n minus 1 plus blah, 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 all the way down to c. Let's say I have some number and I want to consider whether or not it's a 0. So I'm going to call this number c because that's just how it's done by definition in the textbook. So let me change this to a d just so we don't get confused. But I'm going to use a c, and here's what the boundedness theorem says. If we have a c greater than 0 and we divide p of x by x minus c, and let's use synthetic division. So using synthetic division, and after we do that, all the numbers in the bottom row are non-negative. Then there is no 0 greater than c. So that looks like kind of a mouthful, but here's what it's saying. If you have some number that you're going to divide this polynomial by using synthetic division, so you think it's a 0 or a root, but even if it's not an actual 0 or a root, you're just going to do division like you would to check. If you go through and the entire bottom row is non-negative, so you've got 0 or positive numbers, no negatives, then what you've determined is that that number you just divided by, none of the zeros to this polynomial are going to be bigger than that. So if I had some polynomial and I divided it by 2, and I just got like 0, 1, 7, 0, 2, 3, and 4, for example, all in the bottom row, those are all positive, so I know that whatever zeros are in that polynomial, none of them are bigger than 2. Likewise, there's one for negative c's. So if c was less than 0, and we divide p of x by x minus c using synthetic division, and all the numbers in the bottom row alternate signs, then there is no 0 for p of x less than c. So say I divided by negative 2, and then when I do my synthetic division, I got positive 1, negative 3, positive 2, negative 7, positive 8, negative 4, for example. Because the signs all alternated, then I would know that there is no 0 to that polynomial less than the negative 2 that I divided by. One thing that's kind of weird about this is if you have a 0, you can count that as either sign for this part. So, if you did your synthetic division and you had like negative 1, 0, negative 3, 0, 2, 0, 4, you can just use the zeros as either sign. So I could say that I'm going to count that as a positive, so negative to positive, positive to negative, negative to positive. Well, now I broke it because I've got a positive 2 there, but I could make it negative. So then positive to negative, negative to positive, and that'd have to be negative as well. So you can use zeros as like the sign alternators, which is pretty useful. So that is it. That is the boundedness theorem. If you have some 0, divide it into the polynomial. And if that 0 was positive and all the bottom row is positive, then that's your upper bound. That's the biggest possible 0. And if you take a negative c and you divide it and you get alternating signs in your bottom row, then that's your lower bound. There is no 0 smaller than that. And that is the boundedness theorem.